Hi everyone, today we are going to work on graphing log functions. Our essential question is how can logarithmic functions be translated in different ways? So let's work on this example. Complete the table below for the function f of x equal to 2 to the power of x, then reverse the coordinates and enter them in table 2. So first of all, we are given this table with these x values and we're going to find f of x for them. We know that f of x here is 2 to the power of x. So when x is equal to -2, f of x will be 2 to the power of -2. And we know that this is 1 over 2 squared because you flip the base in order to get rid of the negative power. So this will be equal to 1 over 4. So this is 1 over 4. Then we have x equal to -1. So this is 2 to the power of -1, 1 over 2 to the power of 1, and it's 1 over 2. X is 0, it will be 2 to the power of 0. It's 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4, and 2 to the power of 3 is 8. So this is the first table. Now for the second one, we're just switching the coordinates. Like x will be 1 over 4, y will be -2. 1 over 2, -1, 1 and 0, 2 and 1, 4 and 2, and 8 and 3. So now we can graph this table. So for the first one, when x is -2, y is 1 over 4. X is -1, y is 1/2. X is 0, y is 1. X is 2, y is 4. X is 1, y is 2. I forgot this one. And x is 3, y is 8. So if I graph the function, it's going to look like this. And we know that this is graph of parent exponential function. And we already know if we have an exponential function, we have an asymptote here. It's a horizontal asymptote at y equal to 0. So that's the first table. Now for the second one, if I switch x and y, I'm going to get these values. And for graphing, when x is 1 over 4, y is -2 here. X is 1 over 2, y is -1. X is 1, y is 0. X is 2, y is 1. For 4, it's 2. 8 is 3. So now I can graph this function. As you see, the graph is going to go from this side, passes these points, and goes to the negative side on this. So it's getting to -infinity on this side. It looks like we have a vertical asymptote at this point because my graph is getting close to this line but doesn't pass. At x equal to 0, we have a vertical asymptote. We are going to talk more about this later in this lesson. Okay, so what is the relation between these two graphs? As you see, first of all, we switched x and y. That means they are inverse of each other. Also, I see that these two graphs are reflected of each other over this line, y equal to x. They're mirror of each other with respect to y equal to x. That means these two are inverses. These two are inverses. Okay, now the inverse of an exponential function is a logarithmic function. So here we had 2 to the power of x and we found the inverse of that, the graph of the inverse. This is called logarithmic function. So for example, if you have y equal to 2 to the power of x, inverse of that is going to be log base 2 of x. So this is how you write it, y equal to log base 2 of x, and this is how you read it. The meaning of this log is written in this sentence over here. When you have a y equal to y equal to log base 2 of x means 2 raised to the power of what number is equal to x. This is the meaning of log. 2 to the power of what number is equal to x. Now, if you have an exponential function like y equal to 3 to the power of x, inverse of this function will be y equal to log base 3 of x. So you see, I change this to log. The base is the same thing that I have for the exponential function. That's going to be the base of my log. And now it's going to change like this. So the meaning of this log is 3 to the power of what number is equal to x. Okay, now let's talk about this part. Every logarithmic parent function contains these 2 points. What are these 2 points? Similar to exponential functions that we had 2 specific points, the same is here. What are these 2 points? Let's say I put x and as 1. Let's see what happens. So this is my function, y equal to log with base b. I don't know what is the b. It's just a number. Okay, so I just call that b. This is the general form of parent function of log. So this is the general form of parent log function with any base. So when x is equal to 1, then it's going to be y equal to log base b of 1. What is the meaning of this log? As we talked before, we said this means b to the power of a number like y is equal to 1. So b to the power of something is equal to 1. What is that something? B to the power of what number is equal to 1? We know that it's 0 because anything to the power of 0 is always 1. So this point is 1 and 0. This is one of the points. Next, let's put the x as the base. Whatever is the base, I'm just going to put that for my x, replace it for x. So this will be x equal to b. Then the function is y equal to log base b of b. Now, what is the meaning of this log? This means b to the power of a number, b to the power of y, is equal to b. So b to the power of what number is equal to itself? We know that it's 1. Anything to the power of 1 is always equal to itself. So the y value is 1. So these are the 2 specific points. Specific points that my function always contains. And the vertical asymptote for every log function is x equal to 0. Okay, now let's see why do we have an asymptote at x equal to 0. So let's go back here on our graph. Let's see why do we have such a thing here. I'm going to use my calculator to see what is happening here. So first of all, how do I find log on my calculator? I can go to math and then go down here. Here, where it says A, I have log base. This gives me log with different bases. I can use any base that I want. For example, like log base 2 of 4. It's equal to 2. That means 2 to the power of 2 is equal to 4. Okay, so now you see here on top, I have used log base 2 for different x values. When x is 0.25, y is -2. That's the same as this point. X is 1 over 4, which is 0.25, and y is -2. Then I put a smaller x value, which is closer to 0, log of 0.025. Now my y value is getting smaller, it's -5. Then I put a smaller x value. Again, this is closer to x, like 0.0025. Now my y is -8. And if I use another smaller x value, which is closer to 0.00025, this time my y is -11. So I see that as I get closer to the 0, my y is getting closer to the negative infinity basically. But if I use x as 0, Let's see what happens if I find log base 2 of 0. I'm going to get error. That means for x equal to 0, log is not defined. Even if I put the negative value for my x, log base 2 of -5, that's also 0. That means for negative x values, my function is not defined. So I notice here that as x is getting closer to the 0, my y is getting smaller and smaller. It's getting like -5, -8, -11, so it gets closer to -infinity. But my x value is not defined for x equal to 0. This means we have an asymptote here because my function is getting close to this point but doesn't pass this point. So that's why we have a vertical asymptote here. Now let's go to the rest of the problems that we had here. Okay, so here we have transformation of function. This is general form of transformations that can happen on a log function. If you multiply your function by a value like a, this is outside of the function, and a is between 0 and 1, you're going to have vertical stretch here. Vertical stretch. Oh, I'm sorry, I made a mistake. This is vertical shrink, because this number is between 0 and 1. For example, you have 1/2 times log base 3 of x. If the a value is greater than 1, then you have vertical stretch. For example, you multiply 5 by log base 3 of x. If the a value is negative, then we have reflection over x-axis. Next is this part. If you add or subtract something to your x inside parentheses, we know that everything inside the function is kind of weird and acts opposite. So if you subtract a number, if this number is negative, then you are moving to the right. You're moving your function to the right. If the value is positive, then you move your function to the left side. If you add or subtract something to your function outside of your function, like outside of this parenthesis and log, then you're going to move your function up or down. This time, everything is normal. If you have a negative value, you move your function down. If you have a positive value, you're going to move your function up. So let's do some examples here. On this function, -2 log base 2 of x minus 2 minus 3. Let's see what transformations is happening. First of all, we have a negative here. This means there is a reflection over x-axis. Then we are multiplying the function by number 2. 2 is greater than 1, so we have vertical stretch here. Then you are subtracting 2 from x. This means we are moving to the right for 2 units. Then we subtract 3 from our function. This is outside of this parenthesis, outside of this log. So this means we are moving our function down 3. So let's work on these ones. In this function, we have log base 2 of x minus 3 plus 1. So this means we are moving our function 3 to the right and up 1. So how do I graph this? We know that if we have the parent function of this function, it's going to be y equal to log base 2 of x. So this is the parent function of this function. And we have learned that any parent log function has 2 specific points. One of them is 1 and 0. The other one is base and 1, these 2 points. So I can use these 2 points as my parent function and then do the transformations on them. Okay, and also we know that we have a vertical asymptote at x equal to 0 for any log parent function. Vertical asymptote is at x equal to 0. So here I have my vertical asymptote for the parent function, and then I have these 2 points, 1 and 0, and base and 1. What is my base? Is 2. So it's 2 and 1, these 2 points. So this will be the graph of my parent function. Now, how about the new function? It's moved right 3. So any point that I have here is going to be moved to right 3 and also up 1. So this point moved right 3 is going to be here and then up 1. This one right 3 and up 1. So it will be here. Now, if I move my function right 3 and up 1, the transformations are going to happen at my asymptote as well. So I can move this right 3, but if I move it up 1, since this is a long line that is going to continue from top and the bottom, even if I move it up 1 or down, I'm not going to see any change. It's basically the same line, which is just continuing from both sides. So I don't see any changes when I move the vertical line up. So this is my new asymptote. Now the new graph is going to look like this. This will be the graph of my function. Now, what is the domain and range of function? We know that for domain, we move from left to the right, and we look for the x value. So as I move from left to the right, I see that my graph is going to start from right after this line, which is x equal to 3. Okay, so it's x to the 3. It's going to start right after this point. So domain is starting from 3 and goes to infinity. And notice that I put parentheses here because the 3 itself is not defined. We have an asymptote here, so the 3 itself is not defined. This is my domain. How about the range? For range, we move bottom to top and look for the y value. So as I'm moving from bottom to top, I see that my function has an arrow here, so that means it's going to negative infinity. And then from the top side also it has an arrow, that means it's going to continue go to the top, and eventually it's going to cover all the y values from top and the bottom. So it's negative infinity to infinity. Now let's work on this one. On this function, we have a reflection over x-axis because of this negative. Then we are moving right 2 because subtract 2 from x. And then we are moving up 3. So again, let's work on the parent function. The parent function is the same because the base is the same as we had before. So the two specific points are 1 and 0 and 2 and 1. And our asymptote is here. This is the asymptote for the parent function. Okay, so I have my parent function here. Now, what is happening to my parent function? First of all, we have a reflection over x-axis. So these 2 points are going to be reflected over x-axis. That means the y values will be negative. So this point was 1 and 0. If I make the 0, which is the y value, negative, it's going to be still the same thing. So it's here. Then I move it right 2 and up 3. So the point is going to be here. Now this one, reflected over y-axis. So it's going to be, it was 2 and 1. Now it's going to be 2 and negative 1. So it's here. Then I move it right 2 and up 3. 1, 2, 3. So it's going to be here. So now my 2 points are here. Now, how about the asymptote? If I reflect this line over x-axis, again, I'm not going to see anything because this is a long line. And if I reflect it, I'm not going to see anything. Then I move it right 2 and up 3. Again, for moving up 3, I'm not going to see any change. So my asymptote is going to be this one. Now, what is my graph going to look like? This time, you see that when x is smaller, y is bigger. When x is getting like is 4, y is smaller. That means my function is decreasing, it's going down. So this will be the graph of my function. It's going to be like this. And there is an asymptote here, so your function is getting closer to this line but doesn't pass. Now, what is the domain here? Move from left to the right. Where does your function start from? starts from this asymptote, which is at x equal to 2. So it starts from 2 and goes to infinity, and parenthesis for 2 because the 2 itself is not included. Range. For the range, again, you move from bottom to top. From the bottom side, the function is going down forever, and it's going to continue all the y values. So it's from negative infinity. And from the top, again, it's going to continue go to the top. So negative infinity to infinity. Now let's go to the next example. We have log base 3 of x. This is another parent log function, but the base is different. Base is 3. So I can easily graph this with using those 2 points. One of them is 1 and 0. The other one is base and 1. What is my base? Is 3. So the 2 specific points are 1 and 0 and 3 and 1. And also we know that every log function, every log parent function has an asymptote at x equal to 0. So here's my asymptote at x equal to 0, and then my function is going to look like this. The graph is going to be like this. So this is the graph. Now, what is my domain? Move from left to the right. It's going to start right after your vertical asymptote. So from 0, and then it's going to continue to the right. So it's going to cover everything to infinity. Parenthesis for 0. Range, bottom to top, I have arrows on both sides. It's going to continue from both top and the bottom. So negative infinity to infinity. Next, we have log base 1 over 3 of a. So this is another parent function, but the base is 1 over 3 this time. So the 2 specific points, the main points, are 1 and 0 and 1 over 3 and 1, because this is our new base. So where are those 2 points? 1 and 0 and 1 over 3 and 1. So it's going to be like this. So as you see, as you move to the right, your x is getting bigger, but your y is getting closer. That is getting, smaller. That means your function is going to be decreasing. Our vertical asymptote is still the same. Every log parent function has an asymptote at x equal to 0. So this time, the graph of my function is going to be like this. So from this side, it's just going to continue to top. From this side, it's going to go decrease. So notice the difference between these 2 functions. One of them is base 3. That means the function is increasing. It's going to the top. It's going up. But the other one, the base is 1 over 3. Notice that this time your function is decreasing. It's going down. The domain, move left to the right. Still starting from right after the asymptote, which is 0. So 0 to infinity. And range, again, from the bottom side and the top side, both is continuing to go to the top and the bottom. So range is, again, negative infinity to infinity. Next function, log base 4. Again, the same way, the 2 points, 1 and 0, and then we have base and 1. So 1 and 0, base, which is 4, and 1. And our asymptote is still at the same place. This is our parent function with base 4. There is no transformations here. So the function is going to look like this. Okay, so this is our function. It's a curve, it's not straight line. I tried my best to draw the curve here. Okay, now the domain again will be 0 to infinity, because left to the right starts from after asymptote, and range is from negative infinity to infinity. Next one, we have log base 6 of x plus 2. Okay, so the 2 points are, if I have the parent function, let's graph the parent function first. for the parent function, the 2 points are 1 and 0 and base and 1. So 1 and 0, base and 1. These are the points for the parent function. And the asymptote is at x equal to 0. Now, what transformation do I see here? This is up to, because we are adding something to our function. So all these 2 points are going to be moved up to. This one will be here, and this one will be here, up to. The asymptote, if I move it up, it's not going to change because it's a long line. So the asymptote will not change. So my graph is going to look like this now. So this is the graph of this function. Domain, again, starts from 0, goes to infinity. Range from negative infinity to infinity. And now here we have the last function, log base 10 of x plus 5. So here, if I have the parent function will be y equal to log base 10 of x. So the 2 points are 1 and 0 and 10 and 1. So 1 and 0, and then next one is 10 and 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is here, 10 and 1 is going to be here. So these two are my points. And again, I have a vertical asymptote here at x equal to 0. So this is my vertical asymptote at x equal to 0. I'm going to change the color. Okay. So what is my new function? It's log base 10 x plus 5. That means we are moving the function left 5. So the 2 points are going to be moved left 5. 1, 2, 3, 4, 5. And this one also 1, 2, 3, 4, 5. So it's going to be here. Now, if I move the function left 5, does the asymptote also move? Yes. This is also going to be moved 5 left. So 1, 2, 3, 4, 5. So this is my new asymptote. Now the function is going to look like this. This will be the graph of my new function. Okay, this was today's lesson. I hope it was helpful for you. Have a great day.